What's up, everybody? Welcome back. Moving on to another question. This question is going to be dealing with continuity. We have to explain why the function f of x equals 2x squared plus 7x plus 3 over x squared minus 9 is discontinuous at an x value negative 3. And notice that this function is going to be discontinuous at an x value negative 3 because if we plug in negative 3 into the function, this denominator is going to be 0. Negative 3 squared is 9 minus 9 is 0, which makes the function undefined. Now, for a function to be discontinuous, we talked about this in the continuity lecture videos, but the two main reasons are there's either a vertical asymptote or there is a hole. There can also be like a break. That usually happens with piecewise functions though. Notice this is not a piecewise function, it's just a single rational function. So we have to figure out which of these is going to happen. And the way you do that is you want to factor this first. You want to see if anything is going to cancel out. So if we factor the top, 2x squared plus 7x plus 3, that would factor into 2x plus 1, x plus 3. And then x squared minus 9, notice that's a difference of squares. So we'll have x minus 3 and then x plus 3. So notice that the x plus 3's are canceling out. And if you remember from advanced functions, when this happens here, it means that there's a hole at x equals negative 3, at that x value that makes that term 0. So that's the answer to this question. This function has a hole at an x value of negative 3, hence why it's discontinuous. But let me show you how this function is actually going to look graphically, just so you get a better visual. So there's a hole at negative 3. Notice we can't cancel anything else out, so we're just left with 2x plus 1 over x minus 3. That's just a linear over linear function. If you remember from advanced functions, basically there's going to be a horizontal asymptote at 2 over 1, which is just 2. There's going to be a vertical asymptote at an x value of 3. And then the y-intercept, for example, we could plug in 0 for x and we'll have negative 1 over 3 or 1 over negative 3. So that would happen down here. And then the x-intercept would happen when the numerator is equal to 0. So 2x plus 1 equals 0. That happens when x is negative half. So this function is going to look something like this. And like that here. And then at this x value of negative 3, which is like here, there's going to be a hole. So notice that it's discontinuous at an x value of 3. It's also discontinuous at this x value of 3, but for a different reason. At this x value of 3, there's a vertical asymptote. At this x value of negative 3, which is what they're asking for, there is a hole. So make sure that if you're given a function, they're asking for where it's continuous, where it's discontinuous. First off, you know where it's discontinuous. It's discontinuous when x is negative 3 and x is equal to 3, and then also why it's discontinuous. At negative 3, there's a hole. At an x value 3, there's a vertical asymptote.